Hello everyone. So today we are going to talk about a question in Biweekly Contest 83. So that question is the third question, which is called Design a Number Containing System. So we're going to talk about this question and difficulty level for this problem is medium. All right. So now let me give you what this question is about. So we have been given that we will be given many queries. Okay. Initially, they are going to they have told us to make a class. So they have told us to make a class which is called number containers. And what we have to do is we have to either insert a number at a certain index or replace a number at that index. Okay. So let's say if at index 2, so they will say is that they will call the function change. So we have to implement two functions which is called change. So one is change. In this they will be giving us index and value. So what we have to do is at this particular index we have to write this value, or if the value is already present then we have to overwrite it, and if the value was not present then we have to just add it. So let's say initially we have only at zeroth index we have value present as 5, or let's say at first index value present is 5. Now someone has called the function change with the value 2 and 4 with wait a second, with the value 2 comma 4. Then what we are going to do is we're going to there is initially at 2 index there is no value, but when someone is calling the function change 2 comma 4, we are going to write the value 4 at index 2. And let's say if someone again call the value 1 comma 6, then we are going to override this value to 6 and changes to 6. So we have to do this. So this is like normal task, but another thing that has been given to us is that at the end we have to find the number. So let's say uh, using this way we have written like many values. Okay, so at certain index we have written many values. Let's say this is fifth index, this is sixth index, this is 10th, this is 11th, this is 12th, this is 20, and this is 25 index. Now what we have to do is they are going to call a function called find. Okay, so let's say they are calling find 6. Then we have to return the index at which return the smallest index at which 6 is present. We have to do this. Let's say they have called f of 4. Then we have to return to 2. Or let's say they have asked for a value as 50. So we don't have 50 present. Then we have to return minus 1. So this is kind of the question, and like if you don't get it, please read the question first, then come back to the video, or you can just pause the video and read the question. Okay, so this is the thing that we have to do, and looking at it, it could become very easy, but if we just go to the constraints, so the constraints is that there could be the index could be till 10 to the power 9. Okay, so that means that we cannot make a array because array does not support this many elements, 10 to the power 9 elements. That's why we cannot make a array. And numbers as well could be till 10 to the power 9. So this means that this indexing could be till 10 to the power 9. In normal array, this much indexes are not possible. That's why we have to think of a different data structure to solve this question. And we have did the same thing. We have used a different data structure. We have used an ordered map, and we are doing basically two things because we have to also take care of, let's say, what are the things that we have to take care of. We have to take care of index and its value, as well as when someone gives us a value we have to find the minimum index, right? Minimum index, we have to take care of these things, index and corresponding to it the value. And when someone is let's say giving us the value, we have to find the minimum index at which that value is present. Okay, so this could be a thing, but another thing is that let's say we have formed whatever we are going to form, right? But at the end, we have also stored this value as well. Value, let's say for any value 5, we have a minimum index as 2. Okay, but then someone comes and so this is index. Here this is index and this is value. Okay, but then they give us another query. In that query, they say that replace whatever is present at index 2 to the value 10. In that case we have to change this value to. Okay, so that means that we don't only have to maintain a minimum index I, we have to maintain all of the indexes. So let's say after 2 we have 3, 4, 10, 11. So these are the indexes at which 5 is present. So we have to maintain all of these indexes and this as well as in ascending order as well. Okay, so these are present in ascending order. We can do two things. We can either use a priority queue of decreasing order, sorry, a reverse priority queue, or we can use a set. So we are going to use a set of int. So inside the set of int, we are going to store all of the indexes at which the value 5 is present. Okay. And again, to like know at which index what value is present, we are also going to make another array. So what we are going to do is we are going to make two maps. Okay, let me just explain you the question through like the lines of the solution. Okay, so what I have did is I have made a map. So basically, I have made two unordered map. Wait, two unordered map. So in one map, what I'm doing is I'm storing the value as int, comma, set, and the set is of int. And another value or another unordered map is of, so the name is key value. Okay. So this is just going to store the key and its value. So this is going to be int, comma, int. So why we are doing this? So let's say they have given us a value. Let's look at the question only. They have given us that 2 comma 10. At index 2, we have to write the value 10. Okay. So what we have to do inside our solution, what we are going to do is inside the key value map, at the index 2, we are going to assign the value 10. Okay, we're going to do this thing, but let's say before doing this, initially there was some value present already at this index. So let's say this value was old value. Okay, there was an old value which was present at this index. Okay, before talking about this, let's say that we are just going to assign the new value, which is let's say x. So let's say we have like they have called a function change with the value I comma v. Okay, so we are going to do this, and after this, what we are going to do is we are going to like at the key, sorry, at m at index v, we are going to insert I. So we have inserted the index at this value. So using this, we can easily get the index using like the map, using the M map. We can easily get the index. So that's why we are doing this. Okay. So now let's look at the question itself. Okay. So we are going to maintain two maps. Right. Now let's look at the question itself, and now let's see what are the problems that we are going to face while solving this problem. Okay, so we have two maps and we are going to do this. So firstly, they have initialized it, number of containers, and then they are saying us to find whether like at which index, what is the minimum index at which the number 10 is present. So what we are going to do is we are going to look at, so this is like the first query, we are going to look at m of 10. Right, so this set is going to be empty because this is going to point to a set because we have made a map of int comma set. So this set is going to be empty. That's why we are going to return -1 in this case. Okay, so this is the first case, and the second case is they are saying us to assign the value 2 at an index 10. Right, so they have called the function change 2 comma 10. So what we are going to do is we are going to say that at m of 10 at m of 10 insert 2. Okay, so our map is going to look something like this. Let's say this is our map m. So at index 2, we have inserted, sorry, at index 10, we have inserted 2. So this is an index. And another map which is key value. So in this at index 2, we have inserted 10. So this is only storing an integer, but this is storing a set. Okay. Now let's say another query is 110, right? Change 1 comma 10. This is our second query. In this, what we are going to do is we are going to go at 10 index. Again, we are going to go at 10 index and we are going to push the value 1 here, right? So this is a set. So this is going to become 1 comma 1 comma 2. Okay, and at the index 1 we have the value 10. So now let's say they call for value 10, like what is the minimum index at which 10 is present. We can easily get this value and return this value. That's why we are making a set. So this is another thing, and let's say in the third case we have been given 3 comma 10, again another value 3 comma 10. So at 10th index, at 10th value of m, we are going to insert 3, and at the index 3 we are going to insert 10 as well. So these are like the few cases. Now let's say we have been given another case. So this case is quite interesting, and let's say in this case they have given us a value for which we have to overwrite the already written value. So let's say this is something like this. They have given us change 2 comma 11. Okay, change 2 comma 11. So what do you think, what is going to happen when we are going to do this? When we are going to do this, we have to remove this value and this value first, right? So why is that? Because at the value 2 we have right at the index 2 we have value 10%, right? But now we are going to override this value. So when we are going to override this value, this is going to become 2 at 11, and we are going to write here 11 of 2. That means that value present, so value 11, so the minimum, so value 11 is present at this many indexes. Okay, so this means that. But another problem is that this 2 is present two times, here as well as in the previous old value as well, right? So what we have to do is before pushing 2 in this 11, we have to firstly remove this from the old value. Okay, so we can get the old value by looking into the map and then remove this. Then we are going to add it into our new value. Okay, we are going to add this index into our new value. Let's look at the solution now. So I have made two maps, which is like one is m, one is key value, and let's go through the change function first. So what I'm doing is I'm looking that if key value at index is already present. Okay. So in this case, let's say 2 at 10. So initially all of them are going to be 0. And we have been given that values are going to be greater than 0. So we don't have to worry about that. Okay. So we are just going to look that at this index value. So values cannot be 0. That's why I'm doing this. Okay. So what I did was a key value at index should not be equals to 0. So if that is the case, that means that a value is already present there, right? Value is already there. So in this case, we are going to get the old number through the key value or the key value map, right? Using the index, we are going to get the old number, and we are going to erase the old number from our set. Okay, from this unordered map of int comma set, we are going to erase this index. And after this, we are going to just simply insert this number into our set. So insert this index into our set, and also we are going to like make this key value pair as well. So this is going to happen in both of the case when value is already there, and again when value is not there. So we are going to do these two things in both of the cases. So this is it for the change function. For the find function, what we are doing is we're looking at the first value. So let's say we have a set like this. So I'm looking at the begin value. So like the first value is the begin value, and before that I'm looking that if the size is equals to 0, then we just have to directly return -1. And if this is not the case, that means that at least one value is present in our set. Then we are going to return the first value of our set. So this is it, and this is like running fine as well. If we try to submit it, this is going to get success. So if you have any other doubt regarding this question, please feel free to ask it in the comments. Okay, so thank you.